Greetings, students. This is Mr. Torgerson. Today I'm going to do a review for test 2-3. First question. Find the distance between the pair of points. So we're looking here at the length between 0 and 5, as well as the length between -1 and -4. For those of you that prefer, we can use the formula d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. The length in the x here is 5 apart. In other words, the x's are increasing by 5 units. So this distance will be equal to a 5 squared. The length in the x's. The length in the y's is decreasing by 3 units. So this will be a plus a -3 squared. When we square a negative, it becomes a positive. So again, the length here from -1 to -4 is 3 apart. We have a length here of 25 plus 9, or the square root of 34. Sometimes this does reduce. So if this had been a 32, I would have written it as 16 times 2. Which would have made 4 root 2. If it had been a 150, I would have written it as 25 times 6, 5 root 6. Here, because it's 34, it's 2 and 17. 2 and 17 are prime numbers and are non-reducible past that point. Question 2. Find the other endpoint, given the midpoint and an endpoint. So we're looking at a pattern here. To get from -9 to +9, the x's are increasing by 18, so we're going to have to add another 18 to get the other x value, the endpoints. So 9 plus 18 will be 27. 9 plus 18. The y values here, they're increasing by 6 to get from 1 to 7. So we're going to have to add another 6 to get the other y value. So 7 plus 6 will be 13. The other endpoint will be at 27, 13. What we're saying here is that 9 is in the middle of -9 and 27. And that 7 is in the middle of 1 and 13. Question 3. These are alternate interior, so they will be congruent angles. So I will take -4 plus 13x, and I will set it equal to 12x plus 6. I will take 12x from 13x to make x, 1x, or just x. I'll add 4 to 6 to make 10. And then I'm going to verify that the work has been done properly. So here, when I put 10 in for x, I get 12 times 10, 120, plus 6. That's 126. And here, when I put 10 in for x, I get -4 plus 130, which is also 126. These two angles, I have specified them as congruent, so this has been done properly. Next question. These should be supplementary because they're same side interior or consecutive interior angles. So I'll add these together to make 32x minus 12, and they will equal 180 when they add together. I'll add 12 to 180, which will make 192, and then I'll divide 192 by 32. This does divide evenly. X is 6. You don't have to do it quickly, you just have to be able to do it. Substituting 6 back in to verify that these are in fact supplementary. This is 6 times 11, 66 minus 6, which is 60. This is 126, 21 times 6, 126 minus 6, 120. So I have done that question properly. Question 5, exterior angles. The exterior angle of any triangle is equal to the sum of the two remote interior angles. So 70 plus this question mark should equal 130. Therefore, the question mark is 60 degrees. This is called the exterior angle theorem. It also applies to the triangle sum theorem. 70 plus the question mark plus 50 have to equal 180. How did I get 50? Because this is the supplement of 130. So 120 plus 60. You can also use the triangle sum theorem here. Anyway, same thing here, except this is the exterior angle and the two remote interior angles this time. So the question mark will equal 50 plus 75 in this case, which is 125 degrees. And again, I can use the triangle sum theorem to verify the answer here, because 50 and 75 is 125. This angle here would be 55 degrees, and the supplement of 55 is 175 degrees. I'm going to reposition the camera momentarily. And we're back. Question 7, the triangle sum theorem. Every triangle adds up to 180. So this question mark plus 50 plus 80 will be 180 degrees. 50 and 80 is 130. Therefore, that question mark is in fact 50 degrees. What type of triangle is this? Equilateral. Isosceles. If you said isosceles, you said correct. These angles are both 50, therefore these sides would also be congruent. I didn't ask that on this question, but it's a good time to review the word isosceles here. Two congruent sides, two congruent angles. Question 8. Adding the angles again to make 180. So 80 plus 50 plus 59 plus x. Should be supplementary. So that's 130. That's when I add 59 to 130. Well, that makes 189 degrees. So what does that mean about x here? 189 plus x is equal to 180. That means x actually has to be negative. On these types of diagrams, x can be negative if it's written in the format with a triangle added to another angle. The angles in a triangle are always positive. But I'm not saying the angle here is negative. I'm saying x is negative. This angle is in fact 50 degrees. So this is 50, 50, 80 again. This is the same triangle as this in terms of the angles. They're not congruent triangles, however, because the sides are not marked the same. Moving along. Question 9. All the angles are different, and they're all less than 90. So this is going to be an acute triangle. It's acute. It's cute, it's small. The sides are all different as well. Because the angles are different, the sides are all different. So this is scalene. Question 10. We've got a big angle here. An obtuse angle. A large angle. Obtuse. And two of the sides are the same. This is isosceles, which also means two of the angles are the same.
Would the following teachers please report to room 1300, Miss Crabb, Miss Schweitzer.
Sorry about that, I got to record during school hours. So I didn't have to mark the angles and the sides the same here. I could have marked one or the other, and you could have identified this as isosceles. So if I just put the 2.5s here, you would have known the angles here were both 26, and the vice versa is true as well. If I just put the 26s here, you would have known the sides were the same as well. Moving along, let me reposition the camera. And we're back. Question 11. Find the slope of each line. So an x equals line is a vertical line, which has a slope that's undefined. You can also call the slope here infinite. The slope is not 0. A slope of 0 refers to a line that is horizontal. So this has a slope of 0 or no slope, question 13. Question 11 has an undefined or infinite slope. The word no slope means 0 slope. So that applies to question 13, not question 11. These two types of lines are always perpendicular, horizontal and vertical lines. So I can fill this in right here with 11 and 13. Moving along, slope-intercept form. The slope is in front of the coefficient of x, or the x variable, when it's solved for y. So the slope here is 4, and the slope here is negative 1/4. On question 14. Again, that slope is in front of the x coefficient of x, not in front of the x coefficient. It's the coefficient of x. It's coefficient meaning the number in front of x. Question 15. Subtracting x from both sides here to get 4y equals negative x plus 4. And then dividing by 4 to get our slope. M is equal to negative 1/4. The purpose of solving for y is to find the slope and the y-intercept, but I haven't asked you for the y-intercept on these questions, only for the slopes. This is the same as the slope on 14. Lines that have the same slope are parallel. So 14 and 15 are parallel lines because they have the same slope. Question 16. Subtracting 4x over from both sides, we get y equals negative 4x plus 5. The slope here is negative 4. Alright, so let's consider which other set of lines must be perpendicular. Again, perpendicular lines have negative reciprocals as slopes. So I'm looking at specifically the slope of 4 and the slope of negative 1/4 and the slope of negative 4. The two here that are perpendicular are 4 and negative 1/4 because they're flipped or reciprocaled. We interchange the numerator and the denominator of the fraction, and we change the signs. So 12 and 14 are perpendicular. 15 and 14 are also perpendicular. So in fact, there are actually two answers that could go here. 12 with 14 or 14 with 15. If I don't have enough blanks on the test, just put the amount of answers that's there, and you can omit one of them. So 12 and 14, you could also put 14 and 15 here. Not 14 and 15. 12 and 15. They'll also be perpendicular. Alright, complete each congruent statement. Question 19. The picture here is utterly useless. The picture does not matter. It's what states up above that matters. H goes with S. They're in the same spot. So angle H goes with angle S. Don't even look at the picture here. It's just going to confuse you. Same thing applies on question 20. The picture is utterly useless on this type of question, when I've already given you the statement up above. So W goes with U and Y goes with T. WY goes with UT. Segment WY with segment UT, to be more accurate. Question 21. Write a statement that indicates that the triangles in each pair are congruent. Triangle, I would like this to be alphabetical as much as possible. However, I will grade it correct no matter which way you do it. So I'm going to do it as UWZ. UWZ. U is here, W is here, Z is there. Let me move the camera down so you can see what I'm working on here. There we go. Is congruent to, well, U goes with itself because it has the same angle marking. It's got two arcs, so triangle U. W also goes with itself. It's got one marking, so it's angle 1. And Z goes with V because it's got three angle markings. It's angle 3. So triangle UWZ is congruent to triangle UWV. Alright, question 22 through 25. Some of these triangles are congruent. Some of them are not necessarily congruent. So the congruence postulates, there's two of them written here for you. Side, 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 angle, side. The other two postulates are angle, side, angle, and side angle. These are the congruence postulates for triangles. If it's not one of these four postulates, then it's not necessarily a congruent set of triangles. So I'm looking at question 22. There's only two items marked, and there is not a third marking I can add to this because they don't share a side. They don't have a vertical angle between them. So question 22, state if the two triangles are congruent. Not necessarily. Yeah, I'm just going to put the answer of no. Question 23, there's a third marking I can add here because these triangles intersect in an X. So in the middle here there's an X where they intersect, meaning that this angle is the same left and right. I'm going to call it angle 2. So I've got two little markings here. The congruence postulate, I've got two angles on a side, and the side connects both the angles. Notice the side connects both the angles. So this is angle-side-angle congruence. So the answer here that I'm looking for is ASA congruence, or just ASA. The side connects the two angles, or is connected to both the two angles, angle 1 and angle 2. Question 24 has a similar logic to it. Notice here that we have an X on question 24 once again. So this angle will be 90 as well. And this angle of 90 degrees is connecting two sides together on either triangle. So once again we have angle-side-angle congruence. A side connected to two angles, or a side that's in between two angles. Question 25. These two triangles share a side. So I've marked this side at the bottom side 2, this side on the left side 3. It makes sense to mark this one in the middle as side 1. Side 1, side 2, side 3, side 1, side 2, side 3. All the sides are congruent. This will be side-side-side congruence. S, 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 congruence. Let's quickly revisit what it would look like to have side angle-angle and side angle-side congruence. So a side angle-angle congruence postulate will have the triangles drawn in such a way where the side is not between the two angles. So here are two sample triangles. If I were to mark these two sides here, or this side at the top left, and I were to mark the top angle on both of these, which angle would be marked to have a side angle-angle congruence? The left or the right side angle? The right side angle. And I would call it angle 2. This way the side is not connecting the two angles, or is not in between the two angles. So this is angle-angle side, or side angle-angle congruence. I called it angle-angle side on the notes, so I'll call it angle-angle side here as well, even though I called it side angle-angle here on the review. They're equivalent postulates, angle-angle side and side angle-angle. Anyways, so two angles not connected by a side. Angle-angle side congruence. What would side angle side congruence look like? So here's two sample triangles. Let's say this time they're like this and like this. So side angle side congruence. If I were to mark this one as side 1 and this one as side 2 and do equivalent markings here, side 1 and side 2, which angle should be marked on this left-hand diagram, this left-hand triangle? Should it be the left, the top, or the right side angle? Which of these would be the appropriate angle for side angle side? Would be the right-hand angle. What about on this one? Would it be the top, the bottom, or the right angle? It would be the bottom angle. The angle is connected by the two sides, or the angle connects the two sides together. It's in between them. So this here would be side angle side congruence. In other words, the angle is between the two sides. Now if the angle were at the top, or on the right side here, we would not call this side angle side. It would not be necessarily a congruence. Again, if the angle's at the top or on the left-hand side, we call this the ASS, or AS theorem. It doesn't work. Well, except in one circumstance, which we're going to talk about later in the year when the triangle is 90. But the ass theorem is inappropriate because of what it spells and because of what it is. It's an ass. A-S-S. The angle goes between the sides, not the other way around. Not the sides after the angle. Anyways, so that's review 3. If you're liking these reviews, put it down in the comments. I will be coming back probably on Thursday evening around 8 o'clock and reading through the comments if you have some questions that you want to ask. Or come in after and before school. Bye.